Hi everyone. The topic for today's video is factorising algebraic expressions. And I'm going to start this video a little bit differently though. And before we sort of look at some of the formal notes and the formal points of this video, I want you to have a look at these three groups of counters. And I want you to identify, there's something in common. I'll identify what is in common in these three groups. So the first group, we've got a blue and a red counter. Second group, we've got a blue, green and yellow counter. And the third group, we've got obviously a blue, red, green and yellow counter. Now, we've got a blue and red in the first group. There's a red in the third group, but there's no red in the second group. So red is not common. Okay, so when we talk about the concept of common, it has to be the same counter in all three groups. Clearly, it's the blue one. Could we express this a little bit differently? In fact, could we express this? And I guess what I'm going to do is I'm going to put plus signs here. So imagine I'm adding these three groups together. Is there a better way of expressing this? That I could use less counters and that still means the same thing. In other words, I haven't lost any meaning, or the value of this expression has not changed. And of course there is. In fact, knowing that a blue counter belongs to all three groups, why can't I just take out one blue counter, get rid of these two, in fact, and then say, well, a blue counter belongs to the red, a blue counter also belongs to the green and yellow counter in the second group, and a blue counter also is attached to the third group, the group that has the green, red and yellow. And that is the principle of factorising, or at least using coloured counters. We've basically done the same thing. In fact, if you then expand this, and if you recall the previous lesson that we looked at, expansion, where we remove the brackets, okay, and we looked at multiplying the term on the outside to the term on the inside by multiplication, that's putting the blue counter back in again. So if we multiply those, right, that's all multiplied. If you multiply those out, you have blue times red is blue red, okay. Blue times green yellow is blue green yellow, okay. And there's obviously plus signs there, and obviously there's a blue on the outside times this group is blue, green, yellow, and red, okay. So what we've done is we've just expanded again this factorized expression. Now let's have a look at the formal notes. Okay. There's not that many points, but we talk about the concept of highest common factor, and that comes up again. Okay. So what is factorising then in terms of algebra? So factorising is the opposite operation to expanding. We saw that expanding is removing the brackets. Okay. If you remember that this again, the factorising is bringing the brackets back in. Okay. So we're basically doing the opposite. Okay, that disappears. Okay, so there you go, brackets back. So factorising is the opposite operation to expanding. Factorising an algebraic expression involves dividing all the terms by the highest common factor. That's the same as basically taking out, like what we did in the example with the counters, taking out the blue counter. Okay, so you can always go back to the video, go back to the start of the video if you like, watch the demonstration with the counters. When I took out the blue counter, that's like taking out the highest common factor. Okay. So what do? The highest common factor is placed outside the brackets. Okay. If you remember this again, the blue counter represented the highest common factor. Okay. In fact, I'm just going to write that here. There's the HCF there. Okay. So we take that out, put it outside the brackets, and what goes inside the brackets is obviously what's left over when you take out the highest common factor or divide by the highest common factor. Right, let's have a look at some examples. Okay, so now we're not using counters anymore, now we're using algebra. Okay, so again, it's like thinking of the blue counter. All right, what does the blue counter represent in all of these examples? Okay, so the first one, we have two terms, or two groups of counters. One has an x in it, one doesn't, so x is certainly not common. But we do have a 2 and a 4, and we think of a highest common factor, a number that can divide the 2 and also can divide the 4. What can you sort of take out? We can take out a 2. And what we do then is we divide each of these terms by the highest common factor. So 2x divided by 2, that leaves an x behind. And you sort of think to yourself, okay, well 2 times x, if you expand it again, gives you 2x. Great. Plus, because everything's positive here, so put a plus there. Divide the 4 by the highest common factor, okay, by the 2. 4 divided by 2 is 2. Now we can check that if we expand that, okay, so remember, expand. It's a way to check that your factorization is in fact correct. 2 times x is 2x. 2 times 2, or 2 times positive 2, positive 4, and we're all good to go there. Next one, 9 minus 3a. The fact that there's a negative doesn't change anything at all. Again, the a only belongs to one of the terms, okay? So think of these terms like the group of counters, okay? So we have a 3, we have an a. This one, a 9, okay? 9 is really the same as 3 times 3, isn't it? Okay, so we can, in fact, divide the 9 by 3. We can also divide 3 by 3. So why don't we take out 3? That's the highest common factor. 9 divided by 3 is 3. 3a divided by 3, well, the 3 divided by 3 gives you 1, and it leaves a behind. Okay, to check, make sure, again, you got that right. 3 times 3 gives you 9. 3 times negative a, okay, so 3 times negative a gives you negative 3a. Again, good to go there. All right, they're both right. Next one. Okay, 4ab plus 6bc. This time round, well, we may have a highest common factor involving a number and a pronumeral, okay, or a variable. 4 and 6, they're both even numbers. At least we can divide them by 2, and there's really nothing else that could divide the 4 and the 6. We don't include 1. Well, 1 kind of doesn't count because it doesn't do anything. So we've got a 2 as a common, a highest common factor, or at least part of the highest common factor. We have an a in this group, no a in this group. Okay, we've got a b and a b there. Okay, so that's also common, so we can take a b out as well. So what does that leave behind? 4 divided by 2 is 2. ab divided by b, well, the b's cancel, and then we're left with a. What about 6bc now, divided by 2b? 6 divided by 2 is 3. b divided by b, well, that goes, that's already been taken out. The c is what's left over. So they're like the counters that are left over. Okay. 48m squared minus 20mx. Now, just to make life a little bit easier for us here, okay, you don't have to do this, but might be a good starting point just to help you understand the process here. 48mm minus 20mx. Remember, m times m is m squared. Now, let's take out the highest common factor. So between 48 and 20. Now, let's say you're stuck and you think, oh, what do I do? What do I do? Remember this function, okay? Alpha multiplication, GCD. It's a great function. Works. Oh, it's brilliant for this sort of thing. Let's find the greatest common divisor. That's the same as the highest common factor. Just another way to word it. It's 4. So we can take out 4. Now, can we also take out a pronumeral? We have an m here, we have an m here. That's common. We have another m here, but we don't have another m here. We have an x here, but we don't have an x in the first group. So that's our highest common factor. Okay, so remember that GCD function, very powerful. Okay. Right, now let's see what goes inside the brackets. 48 divided by 4, that's 12. Okay, so now we're dividing by the highest common factor. mm divided by m, that just leaves 1m behind. Okay, 20 divided by 4, that's 5. And mx divided by m, the m's cancel, and then we're left with x. Okay, now, how do we know it's right? Expand it again. 4m times 12m. 4 times 12 is 48. M times m, m squared. Check. 4m times negative 5x. Well, 4 times negative 5, negative 20. Okay, so negative 20 there. M times x, mx, another check. Happy. Okay, that's your check. Make sure, do that expansion if you've got a few seconds, especially if this is an exam question, for example. Spend those extra few seconds, expand it again. Okay, satisfy yourself that you know you got the right answer. All right, let's quickly breeze through the last three. A squared b cubed, b squared. Now what's that the same as? Again, you don't have to do this, but I'm just going to do it just for the sake of the demonstration. A squared is AA, B cubed is BBB. A cubed, there's 3 A's. B squared, 2 B's. What's in common? I've got 2 A's here, 2 A's there. So I can take out an A squared. Remember, AA is the same as A squared. You've got a BB there and a BB there. Okay, as long as it's the same letter, you can take out the same number of times. Can't take out 3 B's. I can take out 3 B's, for example, in the first group, but I don't have 3 B's in the second group. So B cubed is not common. B squared most certainly is though. What does that leave behind? So when you divide now by the highest common factor, it's like you're crossing off, okay, A squared, B squared, that leaves B behind there. Again, crossing off A squared, B squared leaves an A behind. Okay, you could write this, because it's positive, you could write this really in any order. It doesn't really matter, B plus A, but you can leave it in that order. Again, does it work? A squared, B squared times B just makes the B squared into a B cubed. A squared, B squared times A, that makes the A squared into an A cubed. Well, I think we're happy with that. All right, last two. These ones involve 3 terms. Factorise them exactly the same way. This one's fairly straightforward. 2, 4, 6. Well, the common factor there, or the highest common factor in terms of the numbers, is the 2. Do we have a pronumeral in common? We have an A here, but no A's anywhere else, so we can't take out the A. We have a B here. There's a B there, but there's no B here. So B's not a common factor. And C, well, that exists in this group and in this group, but there's no C in the first group. So we can't take out any of the pronumerals. So what does that leave behind? 2AB divided by 2 gives you AB. 4BC divided by 2 is just 2BC. When you're dividing by 2, you're just halving it. That's all you do. It's a good way to think of it, actually. 6CD divided by 2 is 3CD. Again, you can expand it. 2 times AB is 2AB. 2 times 2BC is 4BC. And 2 times 3CD is 6CD. Happy? All right, I think we're happy with that. Last one. And this one's sort of a little bit more of a challenging one, but yeah, it still works. Okay. I'm going to write this a little bit differently. X plus x, x squared minus x cubed. Okay. Now, what can we do about this one? Okay. We can see that it's got the same pronumeral. In fact, if each of these can be divided by x, but because we don't have an x squared or sort of a power that we can take out more than one x, we can only take out the 1. So what does that leave behind? X divided by x is 1. X squared divided by x is x. Oh, that's a minus sign, so negative x cubed divided by x, okay, is x squared. Again, expand, check, does it work? X times 1 is x. X times x is x squared. X times negative x squared is negative x cubed. And we're happy with that. Okay. Thanks for watching. Thanks for listening. Okay. Make sure you take down these notes. Okay. Take very special note of the examples as well. Okay. Because this, if you can get this and you understand this, we can extend our knowledge of factorising to much more difficult expressions. Okay. All the best, and also well done.